Okay, I actually just started a recording a second ago and then my computer went all haywire, so I just stopped it and I'm starting over again. So, this is section 2.3, which is immediately following the intro section 2.2. In this section, we're going to discuss different forms of linear equations. And one of the main focuses of this section is to discuss finding the slope of a line. Slope is very important. It's one of the key pieces of information that you can take from an equation or use in an equation. So we want to make sure that we have a pretty firm grasp on how to find the slope based on different scenarios that we might be presented with. The definition of the slope is the rate of change or slant of a line, and it's always going to be designated as the letter M when you're dealing with it. I'm not really sure why, but M it is, so M we will use. There are several scenarios here that I'm going to discuss, and finding the slope is going to be the main focus for all of them. So we're going to begin with if you're in a situation where you are given ordered pairs and you want to find the slope of the line that connects them. So we're going to start by just naming some generic ordered pairs, x1, y1, and x2, y2. Based on these two random ordered pairs, we can use what's called the slope formula to find our slope. And the slope formula sets up a ratio of the change in y over the change in x. So to find those changes, you subtract. And the generic form of this formula is y2 minus y1 over x2 minus x1. And then you'll simplify this, and whatever you get is your slope. So that's a pretty common one, and one that you probably have seen before and heard of before. And we're going to use that one quite a bit when we're writing equations. The second scenario deals with when you are given an equation of a line. Now, equations of lines can look like all different kinds of things. There are two that we are going to kind of hone in on that are actual named forms of lines. So your best bet when you're dealing with the slope is to put your equation in one of these two forms. So the first one is called slope intercept form. The second one is called standard form. Slope-intercept form is the one that most people are very familiar with. Y equals mx plus b. Now, it's very important that if you're going to be putting your equation in slope-intercept form, the y is completely isolated on one side, the x term comes first on the other side, and the constant term comes second. When you have your equation in slope-intercept form, the slope is given in the equation. It is the number immediately preceding the x in this form. So there's your slope right there. When you are in standard form looks like ax plus by equals c. A, B, and C are just numbers. Typically, they need to be integers to be considered actual standard form. And also, A, that number in front of X, is supposed to be positive. So that's the actual standard form. We want X's and Y's on the same side in that order, X's then Y's, constant on the other side by itself. Now, in this scenario, the slope is not just handed right to us. We have to find it. So to find the slope, if your equation is in standard form, you use this formula. M equals the opposite of A divided by B. This is going to set up a fraction, and then you want to simplify the fraction as much as you can. So either one of these forms of an equation will work to find the slope. In an application problem, typically you are given some related information. A lot of times it has to do with a year or a number of years since something occurred, and then some data set. So most of the time you are going to set up ordered pairs based on the information given, and then use the slope formula. So we're going to see an application problem and work with the slope from it. So you'll see that happen. Last is given a special function. And again, I'm going to assume that they are discussing very specific special functions. X equals a number and Y equals a number. So this is where you have a single variable and a constant in your equation. These are special functions in that they represent very specific types of lines on the coordinate plane. So when you have x equals a number, or just x and a number, you want to get it in this form because this type of line is a vertical line. And all vertical lines have the same slope, undefined. The reason why it's undefined is because you are going up or down however many units, but you're not going right or left. So it's like setting up a ratio, a number divided by 0, up or down, but no movement right or left. And this isn't possible. So you get undefined. On the opposite end of that, we have y equals a number, or y and a constant equals 0. This is a horizontal line. And horizontal lines also always have the same slope. M equals 0. And that's because it's the opposite of your vertical line. You are not moving up or down, so you have a 0 on top and then some number on the bottom. And 0 over anything is 0. You will not have a 0 denominator as well. In that case, it would be undefined. So that's not going to happen. So there's our 4 different scenarios. Now we have a few different situations here. So I want to go ahead and take a look at this first one. And then I want to take a look at this third one here as well. And we'll see what it's saying. This equation is in standard form, so you'd set up the ratio opposite of A, so -2 over B, 8, and simplify. Let's work with our slope formula. We'll say the first point is x1, y1, and the second one is x2, y2, and that's pretty standard. And so we're going to set up our little slope formula ratio. M equals the change in y, so y2 minus y1, -6 minus 8, over x2 minus x1, 7 minus -9. And I do write it out like this just so that I don't mess up my signs and I know that I have everything written out correctly. -6 minus 8 more is going to give me -14. And on the bottom, 7 minus -9 actually means 7 plus 9, which is 16. And now -14 over 16 is going to simplify. A negative over a positive is a negative. And we can simplify 14 over 16 because 2 comes out and we get 7 eighths. So slope here would be -7 over 8. Again, this one's a standard form ratio, opposite of A over B. This last one down here is in no form at this point. So we need to simplify this thing quite a bit so that we can see what's actually going on. I'm going to begin by dealing with the parentheses. Order of operations says parenthesis first, so let's do that. X plus 2 over 3 will stay. 2 times 1 is 2. 2 times negative y is negative 2y equals negative 2x. And now the best way that I know about doing this to get rid of this 3 so I don't have to deal with it, I'm going to multiply every single thing in this equation by 3. It's just going to make my life a little easier. Because when I multiply the 3 into this first chunk, the 3 is going to cancel. So that gives me x plus 2, which is good. That's the first one. They cancel. When I do 3 times 2, here I get plus 6. When I do 3 times negative 2y, I get negative 6y. And 3 times negative 2x gives me negative 6x. Now at least my equation doesn't have any fractions in it because I don't want it that way anyway. From here, we get to decide if we want to put it into standard form or slope-intercept form, and it won't matter whichever one you want to do. I'm going to put it in standard form since we didn't see a standard form equation yet. So I'm going to add this 6x over, which gives me 7x. These combined, so that's plus 8 minus 6y equals 0. And then to get it in actual standard form, subtract the 8 over. So we're looking at 7x minus 6y equals negative 8. So now we have our standard form equation. We've got our A term here. B term is here. It does not include the variables, just the numbers. And now we can set up our ratio. So the ratio for slope in standard form is m equals opposite of A over B. And so we're going to take the opposite of the A term, which is negative 7, over regular B term, which is negative 6. And then this does simplify a little bit because negative 7 over negative 6 becomes positive. 7/6. So there's our slope. Oh, here is an application problem. So here's where you're going to see your stuff is not given right to you as an ordered pair. We are going to set up the ordered pairs based on the data. So this is talking about owning some stock, and it's setting up these different pairs of numbers with value per year. So in this one, it's 2,500 in 2003, and then in 2005, it's 3,150. When we set up these ordered pairs with this information, we're going to use year, comma, value. The change is happening in value. So we're going to put the value on top, year on the bottom. Now I want to write these two ordered pairs, again, year, comma, value. So I'm going to use 2003, comma, 2,500. And the other one is 2005, comma, 3,150. And then we use the same slope formula that we use with any other type of numbers. These numbers are just a little bit bigger, but it doesn't matter. It's the same concept. M equals the change in y. So 3150 minus 2500 over the change in x, which is 2005 minus 2003. And then we subtract. 3150 minus 2500 is going to give me 650. 2005 minus 2003 is 2. And this thing simplifies all the way down to an integer. 650 divided by 2 gives me 325. And it's per year, because that's what it's asking, value per year. And a lot of times in these real world examples, it will divide out all the way into an integer and look really, really nice. It doesn't always have to happen that way, but it does often. So there's some background in just finding the slope given your different scenarios. In the next little part here, we're going to graph, and we're going to graph these ones using another method. In the first section, we use the x and y intercepts. In this section, we're going to use the slope and the y-intercept. Now, in order to be able to use the slope and y-intercept, we have to get the equation in slope-intercept form, which we discussed back when we talked about the different types of equations and their slopes. So here it is again, y equals mx plus b. We're going to do a lot of stuff with this equation. In order to put the equation in slope-intercept form, you want to isolate the y on one side of the equation. You want to also make sure that your terms on the other side are in the correct order, because you have to have the x term first and the b term or constant term second. Now, x and y in the equation are going to be variables. M and b are going to be numbers. So, and they're very important numbers. B is the y-intercept, which you can plot as a point 0, comma b. So that'll be your starting point. To figure out where you go from there, you move the slope. Now, there are two different scenarios for slope. It's either positive or it's negative. If the slope is positive, you can move up and then to the right or down and to the left, whichever one you prefer. If the slope is negative, you have to move down and to the right or up and to the left. Typically, I just do whichever one is easier and keeps me on the coordinate plane, because I don't want to go off the coordinate plane. So if I'm too close to the bottom, I want to go up. If I'm too close to the top, I want to go down. So these are the two different things that you could have and the different moves you can make. So let's take a look at this equation so we can see what this looks like. First thing I want to do is isolate my y so that I can get it in the correct form. So there's a couple different things that we're going to have to do. I'm just going to rewrite it so I have room. First thing we're going to want to do is move the 3x over. So I'm going to subtract 3x over, and I'm going to put it in front of the negative 12 because that's where it's supposed to go. It comes first. Negative 6y equals negative 3x minus 12. Then I'm supposed to isolate my y, which means I have to divide everything by negative 6. Negative 3 over negative 6 simplifies to 1/2 x. Negative 12 over negative 6 simplifies to positive 2. Now, as soon as I have my slope-intercept form, I probably want to at least make a note of what the slope and the y-intercept are. And the reason why that's a good idea is because you're going to be asked to do it in the homework, so you might as well just get used to it. So I'm going to name both of them. Slope is 1/2. y-intercept as an ordered pair is 0, 2. And now those are the only two pieces of information that I'm going to need to create my picture. First thing, plot the y-intercept. So my y-intercept is at +2. That's right here on the y-axis. And then to move my slope, which is positive, I can either go up and right or down and left. I'm going to demonstrate both so that you can see them. Slope is 1/2. So up 1, right 2. There's a point there. Or I could have gone down 1, left 2, which puts me on the same line. And then I connect as nice as I can. Since my line tool never works, I'll just connect it. And there's your graph. You technically only need 2 points to create your graph. If Hawks asks for more points, then go ahead and put however many they want on there. But you just continue to move the slope to be able to graph. This equation is similar. I want to talk about this one because we haven't seen one like this. We did see one like part B already, but we have not seen one like part A. So in part A, you should notice right away that you don't have a y in there. So this is going to be one of our special cases, and because it's an x in there, this is going to be vertical. To graph a vertical line, first we have to isolate the x. So I'm going to divide both sides by 2, and I get x equals -7 halves. Now, this -7 halves does not give me the slope. The slope of vertical lines is always the same, and it's always undefined. So that's just something you're going to have to memorize. Now, to determine the y-intercept, we can take a look at the picture of the graph. It's a vertical line through -7 halves. So I go to -7 halves, which is -3.5. 1, 2, 3.5, right about there. Right here-ish. And then I'm going to draw myself a vertical line. 1, 2, 3.5. Right about here. Make it nicer vertical. I'm terrible at using this line tool here. It's the pen. There we go. That's a little bit better. Still not great, but it'll do. You get the idea. Vertical line through -3.5. Now, if you take a look at this picture here, we're trying to determine if we have a y-intercept. Is there a y-intercept on this line? Well, remember, the y-intercept is where the graph touches the y-axis. This vertical line is never going to touch this y-axis. So there is no y-intercept. The second part of this is a horizontal line, which we already looked at. It does have a y-intercept. It does not have an x-intercept. So you can take a look at that one. That one's nice and neat too because it's a nice number. All right, part C. This is probably the most involved part, writing equations of lines. So there are a couple different methods that we are going to have to use to equations of lines. Sometimes we're asked to write our equation in standard form. Sometimes we're asked to write it into slope-intercept form. When I am writing equations of lines, I do not use this stuff down here. You are welcome to use it if you want, but I do not use this point slope form. I don't use any of this. Point slope form is a means to an end. because the equation will have to be written in slope-intercept form and or standard form, I use slope-intercept form to find my equation. So I start here, and sometimes if I just have to find slope-intercept form, I am done once I use this form. If you have to do standard form, you'll just move some stuff around. So I'm not going to use this point slope form here, but if you are comfortable using it and have used it, go right ahead. It does work. Now for me, I use y equals mx plus b. It also eliminates the need for memorizing another form of a line. So the first thing that I'm going to need is a slope. Sometimes the slope is given, and sometimes you have to actually find it using the slope formula. But either way, we need the slope first. Then you need at least one ordered pair. If the ordered pair is the y-intercept, then you're basically done. You're just putting information in. But if the ordered pair is a different point, you can easily find the y-intercept. So the second thing you're going to do is find b. Now, to find b, you are going to substitute in the x and y from the ordered pair and the slope. Then simplify and solve. When you substitute in a number for x, y, and m, the only variable left in the entire equation is the b, which means that you can solve that b value. Once you have your b value, write the equation. Using the m and the b that you just found. X and y will go back to being variables. Then if you have to, move things around to put it into standard form. Now, it's very important that when you put your standard form together, it looks right. And I mentioned this before, so I'm going to mention it again. When you're dealing with standard form here, you are not allowed to use any fractions. So if any part of it is a fraction, you're going to have to multiply by the LCD. And you also want to make sure that the x term is positive. The y term can be whatever. The c term can be whatever. But a has to be positive. And no fractions allowed. That's standard form. So we're going to see this happen. And I'm going to go to this one here, because this one's much more involved. And we have the least amount of information for this problem. So I'm given 2 points. According to my notes, I'm supposed to have a slope and a y-intercept. And right now I have neither of those things. So I can use slope formula, y2 minus y1 over x2 minus x1, to find my slope, and then at least I have half of the information. So I'm going to set this up, and I know these numbers are ugly, but it can happen, so I want to show it to you. I'm going to set up my slope formula. So it's m equals y2 is 9/8 minus y1 is 5/4 over x2 is 3/5 minus x1 is 2/3. It is really hard to tell what that is because I did such a poor job writing it. Let me rewrite the 3 so you can actually read it. 3. Now, in order to simplify this, I need common denominators for the top and common denominators for the bottom because I can't combine them in this form. So I'm going to go ahead and find an LCD. On top, it's 8, so let's bring a 2 in on the right. 9/8 minus 10/8. On the bottom, it's 15, so we bring in a 3, bring in a 5. So we're looking at 9/15 minus 10/15. And so the top of this thing is -1/8. The bottom of this thing is -1/15. Now, this expression here, this ugly looking thing right here, is called a complex fraction. And complex fractions can't be left in this form. So we're going to simplify it by keeping the numerator what it is, -1/8, changing the big fraction bar in between to multiplication, and flipping the denominator piece over. So it'll be 15 over -1. And now we multiply. -1 times 15 is -15. 8 times -1 is -8. And that gives me 15 over 8. So all of that only gave me my slope. Positive 15 over 8. All right, so we're halfway there. But we have some more to do. So I'm going to take my slope that I just found, there's M, and I'm going to select one of these 2 points. And it does not matter which point you choose. Most people just choose the first one, so I'm just going to go with this guy right here. Here's an X, here's a Y. Now the rules say take the X value, the Y value, and the M value and put them into Y equals MX plus B. Y equals MX plus B. Replace the Y. So the Y is supposed to be 5/4 equals. Replace the M. It's 15 over 8 times X. Replace that too. That's 2/3. And then it's supposed to be plus B after that. And now we need to simplify and solve for B. With fractions, there's a little bit more going on. I can simplify this a little bit. This is a 4 and that's a 1. This is a 5 and that's a 1. So we're looking at 5/4 equals, it says 5/4. 5/4 plus B. Well, this doesn't happen all the time. To isolate your B, you have to subtract 5/4. Well, subtracting 5/4 cancels it entirely, which means B is 0. Usually B is a number, but it's fine. So I have a slope, I have a y-intercept, which is 0, so you don't even have to write it. And that means I have my slope-intercept form of my line. So slope-intercept is y equals 15 over 8x, and you do not have to write the plus 0. Now, this does ask us to go a step further and put it into standard form. So I'm going to go ahead and put this thing in standard form as well. First of all, x and y have to be on the same side. And right now, it's y equals 15 over 8x. So if I want my x to stay positive, let's move the y over to the other side. So it's 0 equals 15/8 x. minus y. Now also, we can't have fractions in our standard form. So let's multiply everything by the LCD, which in this case is 8. 8 times 0 is 0. 8 times 15 over 8 is 15x. And 8 times negative 1 is negative 8y. And there's your standard form. Slope-intercept, standard. So sometimes you might have to work with nasty numbers. And sometimes you get lucky and you get nice numbers. It just depends. Number 3 is a special function because it tells you the slope is undefined. When it gives you one of those special slopes, there is no work involved. If it's undefined slope, it's x equals whatever the x coordinate is, negative 2. That's it, you're done. If it's zero slope, then you're talking about a horizontal line, so it's y equals whatever the y coordinate is. So minimal work involved in those. You're really just picking the right variable and the right coordinate. All right. Let's talk about this application problem. And this application problem in this one is dealing with the cost of a bulldozer? Yeah, a bulldozer. And it's talking about depreciation, which means that the price of it is going down, decreasing over time. So we are going to have to use our application information to find a slope, and then use one of the two ordered pairs that we create to write our equation. Same as the last application, except taking it a little bit further. All right, so let's take a look at this, and I need to take a look at it too for a second. So they're talking about the straight line depreciation method, so that means it's going to be linear. I'll highlight some information here. Straight line method means linear. Then it says 3 years ago, Hild Construction purchased a bulldozer for $51,500. Using the straight line method, the bulldozer has now depreciated to a value of $43,200. It says if V equals the value at the end of year T, write a linear equation. So we're going to use V and T instead of X and Y. So I'm just going to make myself a little note over here. V is the Y, T is the X, so that I know when I put them in here. Now this time they don't give you years like they did in the one we talked about, 2005, 2003, and so on. So typically what we do is, for the initial year, meaning the year that you made the purchase, the first year you had it, you bought it, it's brand new, we allow that to be time 0. We got it right then. So that's when time started, basically. So if I'm going to let it be that way, I let 0 years have the initial value. So that would be 0, 51,500. And then I'm going to, I better put that up higher. Hold on, I want to set this up so I have space. So I'm going to let my first point be 0 years, 51,500. That's the initial value. Then it tells us 3 years have gone by. So 3 years ago was the initial time. Now we're 3 years later, which means that current time is 3, and the new value is 43,200. Initial time 0, new time 3. Initial price 51.5, new price 43.2. So we have to find the slope between these 2 points. We use the same slope formula that we used before. M equals the change in y, so 43,200 minus 51,500 over the change in x, which is 3 minus 0. And we subtract 43,200 minus 51,500, and we get negative 8,300 over 3 minus 0 is 3. That does not divide nice, so we leave it in this ugly looking fraction form. Now also, it makes sense that this is a negative slope because this is depreciating, which means that it's going down. So the change should be negative because it should be going down, decreasing. Now, one nice thing about this particular equation is that one of our 2 ordered pairs is the y-intercept. If your x-coordinate is 0, that value is the y-intercept, which means we don't have to solve for b because we already have b. So how nice for us, that saves us a little bit of time. This guy right here is b. And that means I can go straight into my equation. So again, I'm going to use v and t instead of x and y. V is supposed to represent the y, so I'll put v equals. M is negative 8,300 over 3. X is supposed to be a t in this case. And then my y-intercept was 51,500. And there's your slope-intercept form right there. Now, since it originally asked us for standard form as well, I am going to go ahead and put standard form in here. So standard form, which is going to look weird. Normally, they don't do that. It's fine. We'll do it just in case. All right. So if I want to put this thing in standard form, I need the x and y terms, which in this case are v and t, on the same side. Since t is negative, we want to move it over to the left by adding. So that's going to be 8,300 thirds t plus v equals 51,500. And then similarly to the one we did before, we do have a fraction involved. So we're going to want to get rid of that by multiplying everything by the LCD, which in this case is 3. So every term gets a 3. 3 times the first term will just cancel the denominator out. So we've got 8,300 t. 3 times v is 3v. And 3 times 51.5, let me do it real quick, is 154,500. And that is standard form, just in case they want it. I can't imagine them asking you for that, though. So there is some equation writing. So we can see how slope-intercept form can be transformed into standard form when we need it. And we can see how we would use our different formulas to find missing information. Again, just to reiterate, if you are comfortable with the slope-intercept form, not slope-intercept, the point-slope form equation of a line, you are absolutely welcome to use it. I believe that if you go through the Hawks Learn portion, they do use the point slope form whenever they're explaining this. I never use it because I find it unnecessary. They don't ask us to write our final answer in that form, so I use y equals mx plus b. So it's up to you, entirely up to you. So I hope that this helps with section 2.3. Now you have the first two sections of our unit 3. And so we're in pretty good shape. This unit isn't even due until October 27th, so we still have plenty of time, 2 weeks and 5 days or so. So we're in good shape. Hopefully you guys are taking your midterms this week and you feel prepared and ready to go. Those should be graded by the end of the week this week. As I'm kind of slowly getting them trickled in, I'll get them graded, and then I will get those grades into Blackboard as soon as I have them. So take care, and if you have any questions, please email me. And if you need some additional help, make sure that you check the tutoring schedule on the last page of the syllabus. And anytime that works for you, just go ahead and go over to meet with whatever instructor is available at that time. You're not required to sign up for tutoring. So have a good one, and I'll see you guys soon.